Hi friends, this is the lecture number 4 and previously I also explained about the partial derivative. Again we are just talking about the same topic also. Here we will also explain the chain rule also. So in this question he has given you, if x to the power y, y to the power x is equal to a to the power b, then find the dy by dx. So let we are just taking the overall value is equal to u. U is equal to x to the power y, y to the power x, it is coming here, then after the total all value is equal to 0. So if we'll just, you have to find this one, dy by dx. So we can write du upon dx if you will differentiate with respect to x and after then with respect to y, and after then you can also write it dy by dx. Because of this a upon b, b upon c, a upon b into b upon c is equal to a upon c. We are using the same function, okay? Then after then, and you must also note d upon dx a to the power x is equal to a to the power x log a. So at first you have to differentiate with respect to x. So differentiate with respect to x. With respect to x, then this is the constant x to the power a. So y x to the power y minus 1, because this is constant y and we are differentiating with respect to x. Plus it is treating like this, a to the power x, this formula. So this time we are differentiating with respect to x. So it will be treated like this constant is a, so you will write y to the power x and log y, okay? This is constant 0. Again you will differentiate with respect to y. If you differentiate with respect to y, this one, okay, with respect to y, again it is treating like this one, you will write x to the power y, okay? You will write x to the power y, this is x to the power y and this is log x, okay? Then after then you have to differentiate with respect to y, so this will y to the power x means x, y, x minus 1 and x n minus 1. Differentiation of d upon dx x to the power n is equal to nx n minus 1. We are using this formula and this is the constant 0. Then after then you have to divide, then you will get the answer, okay? So now the second question, okay, just we are talking about the chain rule, okay? What is the chain rule actually? Suppose you have this question number 2, u is equal to f of this, you have this question, you have question x upon y, okay? Then after then you have question y upon z, okay? Then you have question z upon x. He is asking prove x into ux plus y into uy plus z into uz is equal to 0. What is the meaning of ux? Already we have written, means zx, means we are differentiating with respect to x, we are differentiating with respect to y, we are differentiating with respect to z, okay? Means del u upon del x, del u upon del y, del u upon del x, del u upon del x, del u upon del y, del u upon del z. It means that this, okay? So at first this we have to differentiate with respect to x, then with respect to y, then with respect to z. But there is a problem. What is this actually? This is the problem. So how to solve such type of problem? This is a very difficult. So we are taking this x upon y. This x upon y, we can take any another value, that is r. We can take any value. Y upon z, this, suppose we are taking y upon z is equal to s, and we are taking z upon x is equal to t. You can take any value, p, q, r, or you can take any value, okay? So now you have to differentiate. It means that your u, it has become f of r s t, okay? It means that this is a function where you have three variable r s t. This is a function where you have three variable r s t, okay? So this overall function you are representing by u, okay? This function you have to differentiate with respect to x, with respect to y, with respect to z. He is asking 0. He is asking that prove that this is 0, okay? So how will you differentiate? So at first you will find du upon dx. How to find du upon dx? This is the question. So del u upon del x is equal to, so you will write del u upon del r at first there are total in this function, actually u means there are total number of 3 variable in this function. So you will differentiate, if you are differentiating with respect to x, so at first total number of 3 variable in this function. So at first you will differentiate with respect to r, then with respect to s, then with respect to t. So at first we are differentiating with respect to r, then we will differentiate with respect to s, then we will differentiate with respect to t. So in a function, if there are total number of 3 variable, then you will differentiate one by one with respect to r, with respect to s, with respect to t. Okay, that is the chain rule actually. Okay. After then in r, in the function r, okay, so in the function r, there is a variable x. We are differentiating with respect to x. So in this r, you can see that r is equal to x upon y. So in this r, there is a function x, means you will differentiate this function with respect to x. It means that del r upon del x. Okay, then plus. Okay, now del u upon del s. In this s, in this s, you will differentiate with respect to s. Okay, with respect to s, x, because we are differentiating with respect to x, so we will differentiate with respect to x, then we will differentiate with respect to y. Okay, so it means that del s upon del x. In this s, we will differentiate with respect to, because overall we are differentiating with respect to x. Then plus, we will differentiate with respect to t. Now in this t, there is also x. We will differentiate this t with respect to x, because we are differentiating with respect to x. That is the way to write. So at first you have to learn how to write. That is the chain method. Okay. So now it means that du upon dr is equal to, okay, you must know that what is du upon dr, what is dr upon dx. So if you will differentiate r with respect to x, then you will get 1 upon y. Okay, but if you will differentiate s with respect to x, s, what is s? S, there is no x, so this is 0, this is 0. If you will differentiate t with respect to x, okay, there is some value. Okay, this is 1 upon x, means minus 1 upon x square. Okay, so you will get this answer. This you will get du upon dr. We don't know about this, but we know that dr upon dx. So dr upon dx means you have to differentiate this with respect to x, then you will get 1 upon y. So you will get 1 upon y and du upon dr, del u upon del r. Okay, but this is 0. Then after then plus del u upon del t, and del t upon del x means this with you have to differentiate with respect to x. Then you will get z upon minus x square. Then you will get minus z upon x square. Differentiation of 1 upon x is equal to, you have to remember this is 1 upon x square, because it will come above x to power minus 1. Then you have to differentiate, you have to use this formula, d upon dx, x to power n is equal to nx n minus 1. So n x n minus 1. So you are getting minus x to power minus 2. Then this is minus 1 upon x square. So we have written this one. Okay. So z is z. Okay. You have to differentiate t with respect to x. Z is constant and 1 upon x is equal to 1 upon x square. This is the first answer. Similarly, you have to differentiate y with respect to y, means del u upon del y. Del u upon del y. How to write? Again, I am just explaining you. So you are differentiating with respect to y. In y, you are differentiating u with respect to y. So in u there are total number of 3 variables. Okay. So you will differentiate u with respect to r. You will differentiate u with respect to s. You will differentiate with respect to t. Okay. But we are differentiating with respect to y. So now you this r is also variable. R is equal to something. You will differentiate r with respect to y, because we are differentiating with respect to y, plus now this we are differentiating s, because s is also one variable. you are function actually, okay, you are differentiating with respect to y, because this is y, plus now t is also one function, and in t there is two variable. The t with you are differentiating with respect to y because this is y, so differentiate or t upon del upon y, okay. Now again you have to find this one, okay. If you will differentiate r with respect to y, then you will get same thing, minus 1 upon y square, minus x upon y square, okay. So minus x upon y square, this, but this is same, del u upon del r, okay. Now this one, you have to differentiate with the s is this, with respect to y, then you will get 1 upon z, plus 1 upon z, and del u upon del s, this is same. Then after then t, you have to differentiate with respect to y, but there is no y, so it means that this is 0. So you got this, one is this, one is this. Now the third one, we are just talking about the third one. There is no space, so I am writing here, okay, del u upon del z. What is del u upon del z? In u, there are total number of 3 variables, r, s, t. So one by one you will differentiate with respect to r, with respect to s, with respect to t, to u. So del u upon del r, then after then plus del u upon del s, okay, then plus del u upon del t, okay. Now this is also a function, this r is also a function. You will differentiate this r with respect to z, okay. So del r upon del z. Now this is also a function, this is also a function. This function you will differentiate with respect to z. So del s upon del z. Now this is also function, this is also function. You will differentiate with respect to z because of this. So del t upon del z, okay. So now this value it will come, okay. So del u upon del z is equal to, now what about dr upon dz? R you have to differentiate with respect to z, but there is no z, so this is 0. Then after then del u upon del s, I don't know what is this, del s upon del r, okay, del s upon del z, sorry, del s upon del z, you have to differentiate, then you will get minus y upon z square, minus y upon, sorry, minus y upon z square, okay, this value, plus now this t you have to differentiate with respect to z, then you will get 1 upon x, then this is 1 upon x del u upon del t because of this, okay. So now you got this one. So this is the equation number A, this is the equation number B, and this is the equation number C, okay. This A, B, C you have to put here because you have to evaluate this. This is 0 actually, you have to evaluate. So now you will del u upon del x, whatever you have got, you will multiply by x, this you will multiply by y, and this you will multiply by z. Now you can see, if you will multiply by x, then after then you will get x upon y del u upon del r, okay, this. Then after then you will multiply by x, then x and x cancel, minus z upon x del u upon del t, okay. Then plus this, you will multiply by y, then you will get minus x upon y, y and y cancel, del u upon del r. Then you will multiply by y, then plus y upon z, del u upon del s, okay. Now in this equation you will multiply by z, then z and z cancel, minus y upon z, del u upon del s. Then you will multiply by z, then you will get z upon x, del u upon del t. Oh, now can see x upon y del u upon del r, x upon y del u upon del y, del r, this is minus, this is plus, both cancel, okay, this cancel and this cancel. Now z upon x del u upon del t, z upon x del u upon del t, this is negative, this is positive, both cancel, okay. Now this is y upon z del u upon del s, y upon z del u upon del s, this is positive, this is negative, both cancel, it means that this is 0, okay. This is the answer. So every time they will ask you question how to solve such type of question. So chain rule, in the chain rule also we have to solve this question like this. This is the, so we have solved here chain rule also. Okay, in this lecture we discuss also chain rule and also total derivative. Okay, thank you so much. My request to you, please solve more and more questions to get success. You must learn the concept how to write. Okay, just listen, pause the video and listen again and again. Then you will get the real concept of the partial derivative, the mathematics, the computer science, the programming, everything to get success in your life. Okay, thank you so much.